Hi, everyone. Welcome to today's webinar on X-Rite Inline Solutions for paper. Presenting today, we have Freddie Binder, the Sales and Marketing Director for Munich Inline Solutions. I'm Amanda Carter, one of X-Rite's North American Marketing Managers, and I will be moderating today's webinar. A few things to go over before we get started. Due to the number of people that are attending today's webinar, we will keep everyone muted. During the webinar, if you have any questions, please use the questions function on the GoToWebinar panel. We will have some time at the end to answer a few questions, and if we don't get to yours, we will have someone follow up with you. Finally, this webinar will be recorded, and you will receive a link so that you can review the webinar at your convenience. I'll now turn it over to Freddie.
Hello everybody and welcome to this session, Inline Color Measurement and Closed Loop Color Control in the Paper Industry. Let me start this session with two questions at the beginning. So first question, why is it so important to talk about color? I mean, we are all standing here talking about color. There must be a reason for it. Well, if you look at these packages, I have made this picture now and they should be all with the same content, but you see some packages are different. What do you think of the quality? Which package would you pick, honestly? If you look at these packages, it's the same store. A small one and a big one should fit together. Is the color inside really the same? Or if you look at the shelf, this is really in our office in the shelf, which we have inside the folders, and you see also here are different colors. The problem is, everybody can see that the color is different. You do not have to be an expert. You do not even have to have a color measurement system to see it. Everybody sees it, whether you're a child, whether you're an adult. So color is a primary quality criteria. And this is what makes it so critical to us. And now let me go to the second question. If we can see the color, why should we measure it? Well, if I show you this color swatch here and try to remember it, because I will move it away and I show you a bench of 16 new colors. Which color was it? You see, it's difficult. We cannot remember it. We have some guess, but I guess if I make a voting, we will get everything, but not the right one. Even if I show you this color now, it's difficult which color we talk about. We really have to take this color and move it around to see which color fits best. And you see, only if it's side by side, we can recognize, number N is the right one. So we have no color memory. And that's the reason why we need to have color measurement systems to recognize whether the color is correct or not. Okay, this was more globally. Let's go into the paper industry. If we talk about paper production, why do we have color errors or color changings on the machine? Well, if you have a raw material, especially if you have waste paper or recycling paper, the raw material can have nearly any color, but at the end of the machine, we want to have the same color. So the fillers, if you use fillers like calcium, carbonate, clay, or whatever you use, they come from different mining sources. They could have different colors as well. Look at the additives, everything you put inside, retention agent, fixatives, the pH value, everything influences the color of the paper. If you have dye stuffs and you dilute them, if you have different dye stuff concentrations, if you do some errors, and even if it's little errors in the concentration, you will have these errors on the machine. So everything on the paper machine is influencing the color, but at the end, if you make the paper should always be nicely constant, having the same color. And I think this is not easy to achieve. If I talk about color measurement, it's not only color which we are looking on. So we are measuring basically a spectral curve. So if you look at laminate paper, test liner, then it's really only color which we measure. But if you look at newsprint or tissue, then opacity also becomes very important. And if you look at some other papers like white papers, cardboards, graphic papers, white coated papers, offset papers, whiteness and brightness is important as well. So we have all over the world approximately 700 installations in the paper industry. And I would say altogether it's more than 1,000 installations. you see that our biggest market is for sure the paper industry. So this is where we are strong. And I wrote successful installations because I know paper makers are very well, have a very good network in between each other. If you know somebody who is using our inline system, ask him how happy he is with it, because we have no bad references. It doesn't mean that we have no problems, but we fix them. So this is about the color. If you look at a paper machine, what can you expect? So if we have this inline color measurement system, we have much shorter startup times and shade change times, so we can save approximately 50% of getting the color to the right color. We reduce the waste. This is also typically 50% of the waste, which is caused by color, will be reduced. If you have a measurement on the machine, you can react immediately, even before the color is out of the tolerance. So this helps the operators to drive their machine. You have a documentation of the entire production. Well, this sounds nice to have, but if you have no color measurement, somebody could come over and you can say, you know, at the beginning and at the end of the roll, we had the color was correct, but right in the middle of the roll, we had some problems, so we have to reduce the price. If you have a reliable color measurement system, you can prove that the color was well everywhere, and this is also a marketing aspect for you. And of course, only if we have the color measurement, we can make a closed loop color control. So if we talk about a system, it's not only like this, that we sell a piece of instrument and a piece of software and tell to the customer, help yourself. We have really customized systems. That means we build a frame which fits exactly to your machine. And this is not just a frame going inside the machine. This is a frame which moves the instrument away if there is a sheet break, which lowers the lower arm so that it can feed up the paper and then have enough clearance to feed up the paper. When the paper is on the machine, it closes again. We have some control boxes, a frame control box to open it, power supply box to have the power on the instrument. And then typically the operator's room, the control room, is far away from the machine. So we can have a long line up to the instrument. And then we have another box very close to the computer to transvert everything to a USB signal. So the signal or the computer which we use can be a regular computer, no special thing. We just need a USB port and we can control everything on our side. And of course, if we talk about the closed loop control, we also need pumps over there. So we connect the pumps kit to the computer as well. And if you want, we can also connect to your DCS system through OPC or any other link. If I'm looking at the paper machine, we have three possibilities where to measure. So this is a very basic paper machine. You see on the left-hand side, there is a chest. We have the screen section, the press section, and the drying section. First possibility where we can measure is the pulp. But this is only a kind of pre-warning system, so it gives you an idea if something is changing at the beginning of the machine. Unfortunately, it doesn't show the color of the finished paper. The second position is here between press and drying section. This is interesting for laminated paper, because on the laminated paper, we are interested how the paper looks when it's laminated on a piece of wood. So when it's drained with melamine resin. Here, when the paper is wet, it has the same look like if it's glued on a piece of wood. This is the reason why we measure in this wet section over here. But the most interesting point is at the end of the machine, where we roll up everything, because here we have the paper, which is the finished product, typically what you sell to the customer, and we have an excellent correlation to the laboratory. So the end of the machine, this is before reel-up, this is the mostly used location. As I mentioned already, we correct our values to the laboratory. So we say the laboratory instrument is always right, and we want to adjust our values to the laboratory. Here we can measure not only the color, but also the optical brightness, of course. And this is normally the position which we choose if we want to make a closed loop color control. So this is how the system looks like. I think the video does not work on a streaming like this. So you see, this is the customized frame, and the instrument will swing away during production. You see here another frame. This is also a brown paper machine. This is an interesting thing, which is very typical for America especially, but now it comes over more and more in Europe. It's a Gemini system where we measure from top and from bottom, so we can even control the two-sidedness of the paper. We have one instrument on top, and we have one instrument from the bottom, and both sides are measured, both sides are controlled. And this is how a system looks when we install it. So typically we make pictures always when we install the system. This is a system which is running for, I think it was only 2 months. So you see it's very dusty, it's very, very dirty. The spot you see right in the center here, this is the measurement spot. So here we normally have the flash. When we, by the way, this instrument now is in a service position, so there is no paper on the machine. This is the reason why you can see the measurement spot. The measurement spot is normally closed. Only when we flash, we open it. And you see we have air flow over here. So the air is coming to the inside the instrument. If we open the shutter, the air is flowing out. So the dust will not go in. It's only from the outside, and we have reliable measurements. This system is really measuring fine even when it's dirty from outside. This is how the software looks like. You see we have here 5 graphs. The first one, the black and white ones, these are the L values. The second graph is the A star value. It's red and green values. And the third one is the B star, yellow and blue side. Then we have a delta E, and we have an opacity on the bottom. And you see it's very easy to recognize because the color of the bars show you what the color on the paper will look like. So if I look at the very last measurement, we are slightly too light, slightly too green, and a little bit too yellow. This gives you, on the first glance, an easy indication where you are. The bigger the bars, the more you are away, and the color shows you in which direction. So this helps very easy for the operators to adjust the colors or whatever. Everything I talked until now was about color measurement, but I had a second topic, which was the closed loop color control. I have again my paper machine here, and you see we have the measurement at the end. We show the results on the computer, and then we know where we are and we know where we want to be. So we do a kind of mathematics. We have a mathematical model, and we go from all the 3 pumps. We give a signal how to change to get to the right color. And it's really, we change all 3 pumps at the same time. And if we have optical brightener on top, we can even change 4 pumps. And what you see in this drawing is the brown color, which goes directly into the chest. So we can also work with a pre-dyeing. If you have high saturated colors, it sometimes makes sense to make a pre-dyeing, let's say 80–90% at the chest, which could be much cheaper. And then we make the rest right in front of the fan pump. This is the typical dosing point where we put the colors inside. So this is then the loop. We change the dyes, wait until the new color arrives at the instrument, and then we make another step to adjust the pumps. Why is it so complicated, and why are we so fast, let's say? The reason is, this is what everybody wishes. You want to have one color which goes to the L value, another color which goes to the A value, and another color which goes to the B value. This is a nice wish, but in reality, it doesn't work. If you change one color, all these 3 values are changing. So if you have a color shift somewhere on your system, you have basically 6 possibilities. You can decrease or increase the blue, you can decrease or increase the red, and the same for the yellow. And then this makes it a bit complicated, as everything is influencing everything. If you have on top of it the OBA, it's even more complicated. And this is what the software helps you. We are not guessing how the color was or how the color is. We are really calculating what has to be done with all the dyes to get on one step, theoretically on one step, to the right color. We have a so-called gain factor in our software. If I say in one step, theoretically, yes, theoretically it's one step, but normally paper makers try to be a bit more conservative, so we try to adjust just 80% and to go in 2 steps to the right color, because what normally we do not like is to overswing and then have to come back. So this is the reason why we normally be a bit more conservative, but theoretically the calculation would be how to get to the target in 1 step. And that makes it very efficient. Why does it save so much in our time when we set up a machine or when we do a color change or a shade change? I have shown you here the ways how we do it normally. So if you set up a machine or if you make a shade change on the machine, you have to adjust a lot of parameters on your machine. So this starts with pulp flows, with the width of the paper, caliper, chemistry, pH value. There are a lot of things which the operators have to do during that shade change. And most of the things are influencing the color. So what the operators do, they start to set up the paper as it is, and at the end, when everything is fine, they start to make the color, which takes another time. So if we have a closed loop control system, of course we cannot change this beginning. We cannot make the pulp flows quicker or the width done automatically or whatever. So this is the same time. But at a certain point, when the paper makers see that they are close to where they want to be with all these parameters which they have to adjust, they press a button and the closed loop control works in parallel. So we are setting up the color automatically. It's just one press on a button. And then when the paper makers are done, the color is done as well. So that means at the end, this is how much they save with the startup. And typically, really, if you make a shade change, this is 50% of the time. If I look again at an overview of this closed loop color control, what does it help? So the color changes are done in automatic mode, which helps the paper makers to get to the color quite easy. So the color will be done independent of the skills of the operator. We all know this. You have shifts which are making color changes quite quick, and other shifts need a bit longer. So it's a question of the operator. In this case, the correction will be done automatically, and it's totally independent of the operator's skills. All these color changes will be done in parallel to your machine setup. So as long as the operators are setting up the machine, we do the color change in parallel. No extra work for the operators, just pressing one button. And typically you save a lot of time. So 50% of the time, which is normally used by a skilled operator, is used for our closed loop control to get to the right color. So that means it makes it much quicker than the operators do it, because it calculates the colors. Well, the closed loop control provides on-time process correction. So that means all the time we are looking at the color, or the system is looking at the color, and it makes corrections, even if it's small one. If you have let's say if you have a brown paper test liner or something like this, where you have normally huge tolerances, the system keeps the tolerances typically within 0.2, even if you have waste material, which is changing the color and everything. So this is quite nice. You have a nice quality, which for marketing purposes, it would be nice to sell a product which is quite stable, even if it's not totally necessary. It minimizes off-spec production. Sure, if you are always checking the color, you will have no overdying or whatever, so that the color goes out of spec. The uniformity is much better. As I said, 0.2 is a typical value which you have even on bad raw materials. So you have a very nice color. The printers or your customers afterwards, they like it, and they use this, or they have a real big advantage to have a uniform color for their printings. And of course, the closed loop control takes the guesswork out of the process. We calculate it. We do not have to think about, do we need 1 or 3% more red? We know it's 2.67% more red. and at the same time decrease the yellow by 2.63% and whatever. Was it from my side? Any questions?
Looks like we had a couple questions come in during the presentation, Freddie. One of them, how fast can the speed of the paper be?
We measure with a flash technology, so we have a xenon flash lamp inside, and you can imagine this is like a camera. If you make a flash, the paper stands it's like the paper stands still. So we have paper machines which are running up to 2,000 meters per minute. How much is it in feet? Good question. Times 3 maybe, huh? 6,000 feet per minute. And this is no problem. So the speed of the web or of the paper is no problem for measuring because we have this flash technology.
Great. Is there any influence with ambient light or on ambient light?
It's also to answer with the flash technology. So the xenon flash is much stronger than the ambient light. On top of that, we measure right before we do the flash. So we measure how much is the ambient light. Then we make the flash, and we have basically as a signal the ambient light and the flash. If we subtract both signals from each other, we have only the flash. And this is the reason why the measurement is quite stable, independent of ambient light. So you can really prove it if the sun shines on the paper or not. It doesn't matter. You can take a flash lamp, flash on the spot where we measure, or flash into the instrument, no problem at all. It's totally unsensitive to ambient light.
Great. That was the last question that we have time for. So this marks the end of our webinar. Thanks everyone for joining. If we weren't able to get to your question, we will definitely follow up. And you will also receive an email with a link to the recording of this webinar. So thanks again for joining. Thank you, Freddie. Everyone, have a great day.
Thank you, everybody. Bye-bye.